All right, welcome back. We are GAME3001. That's Game AI in the winter 2020 semester, and it's week 13, part 1 of our broadcast. We're going to be talking about SDL animation system and how I kind of use Texture Packer for that. Okay, so that's this. To start off like we normally do, there's all my crazy drawings from last time. And I also have this crazy thing here. I'm going to do a bit of a challenge today. So today's a challenge day that we're going to be talking about. So let's start off, though, with our the stuff that I've given you. So if you look up online on Blackboard, please, that's the first thing I want you to do. On Blackboard, if you go to Labs, and if you go to week 11, basically it's Lab 11, you have a few things to download. One of them is this SDL template version 9.1. So please grab this. Please grab Texture Packer Exporter. I need those two things, right? And I also want you to grab the Triggers in Action Word document, the Assets version 2, and the Sprite Sheet. So just download all this stuff for me right now, and then I'll tell you when you're supposed to use all this stuff during the lesson. Okay. I'll wait for you guys to do that for 1 sec. Now I have two screens. I have one screen in front of me and I have another screen over there. So if you have any questions, please put it in the chat, and then I'll see it on this screen over here. I'll occasionally look over there if you need to. You can always open up the mic, but if you do so, then your question may be recorded on YouTube. And I'm okay with that as long as you are. Okay, so that is what you're downloading. I'm assuming that you're downloading template 9.1, and I'm going to do the same thing. So I'm going to go up on here, grab template 9.1. I'm going to copy it. I'm going to go out to the desktop and go into GAME3001. And then once I do that, I'm going to, let's try that again. GAME3001 and just paste it. Okay, so when I paste it, it's going to copy everything into that folder. And again, there's a bit of lag, a bit of delay between what I'm doing and what you're seeing, and that's okay. I'm going to rename this thing, so it's going to be GAME3001 in the winter 2020 semester, and it's going to be lesson 11D. Here's the lesson 11D. And just like always, I'm going to make a new GitHub repo with it. So I'm just going to use VS Code to help me out here. So drag and drop this into VS Code. And I'm going to press Control Backtick, which is going to allow me to get the terminal. I'm going to say git init, git add dot. As I'm creating my repo, git commit -m initial commit. And then what I want to do is want to go back up to GitHub and grab the GitHub link for this and push this on GitHub. So you'll have this, everything I do today, up on GitHub with the latest version. All right, so that says please remind me at the end to push, and then I'll push this up to GitHub. All right, so let me just minimize this one and open up this one. So this is Visual Studio. The other one was Visual Studio Code. I just used it as an editor, and the other one I'm using as the IDE. Okay. All right, so last week we had a discussion about, hey, I want to have these kind of assets, and inside my assets I had some sprites I showed you. One of the sprites was the Megaman idle sprite. So we talked about this. We had a Megaman idle sprite, and it looked like this. There's a little strip. I'll wait till you guys update. You guys are updating nice and slow now. There's Megaman idle. And also, there was Megaman runs. There's two strips. Okay, little animation strips. So yeah, we can make this work for sure, right? We had 2 strips, and what we would do is we would start with idle, we would load this strip of animation, do the idle animation, and then we would load up run, and we'd do the run animation. Now, disadvantages of this is each of the strips had to be exactly ordered correctly. In other words, each of the frames had to be separated exactly equally. If they weren't, that would be a problem, right? If I had multiple animations on one line, right, they would have to have the same number of animations on each line. So 4 here, and if I had a second line of animations, 4 there. Okay, you couldn't have 4 here and 2 there, just the way that that draw frame function worked. Okay, and again, I'd have to iterate from one animation to the other and then repeat over and over again. And it'd have to be in its own sheet like this because, you know, again, unless I had everything in a row or in 2 rows, it'd be a bit of a problem. And I talked about how this could be bad. What if I wanted to pick a specific spot to read from? I need to know what this frame is, what it's called, and what I'm reading from. And I have no way of, none of these frames is named at this point. They're just a bunch of frames in an animation. I'm just going from one to the next, right? So where this is bad is where I want to use, I should refresh this, is when I want to use some kind of tile map set. So imagine if I had a tile map like this, and I wanted to kind of look at this tile here, top left corner, and then I want to look at like some kind of you know, tile in here, right, where I want to have a wall. Maybe I want to have some clouds, you know, whatever, and I want to pick different you know, textures that I want to lay out on my background or my foreground and wherever I want, and there's no way I can do it with my current animation system. So that was kind of what pushed me to make another one. Okay. And of course, there's going to be 2 parts to this whole thing. There's going to be the part where I serialize everything or encode everything through a tool called Texture Packer, which I talked about, right? So I talked about this tool, Texture Packer. This is Texture Packer, right? And Texture Packer is a paid-for tool, so it's worth, I think, $59.99 Canadian at this time, right? If you go on the website, you can certainly download and pay for it if you wanted to, or you can download a free trial for 7 days. Now, if you have more than one of you in a team, I think this might be a great solution to try it out for, you know, a couple weeks and see if you like it. If you're going to be someone who's going to be using or making 2D games, Texture Packer is for you, because the great thing about Texture Packer is it handles 2D sprite sheets and all that stuff nicely, and there's a lot of work involved if you're doing it on your own. So if you look at your project for a second, inside of your Sprites folder, you have 2 files. One of them is called atlas.txt, this one, and you have an atlas.png, which is this one. And this atlas.png and the atlas.txt was created for you. This is made for you by Texture Packer. I also have a TPS file, an atlas.tps file. So if you had Texture Packer, right? If you had Texture Packer, then you can pull up the project to see how I dragged and dropped stuff in here. Now, last week I did not have an exporter. Notice now that the framework is pointing to it as SDL, because this is the framework that I made. I made the SDL, this kind of an exporter for this. I've given you this up on Blackboard. So if you look at Blackboard, the second download is the Texture Packer SDL exporter. All right, and all this is a custom exporter that outputs a text file that looks like the one I showed you, this one. Okay, so that's all it is. It doesn't do anything else other than that. Just exports, you know, or creates a text file with all the frames. Okay. Well, that in the actual sprite sheet texture. Okay, so where is this and how do I set that up? Well, if I'm in Texture Packer, once I've downloaded it, you can put that folder anywhere you want on your system. You can go to File, and if I go to Preferences, I can point to a custom extension. Under Custom Exporter Directory, I can point to the exporters folder that I have, and any new exporters you make will be found here. after you set this up, you need to close and restart Texture Packer. But then what happens is now we have access to this new exporter called SDL, which I made for you. Okay? So what does this do? It creates, if I looked at the files for this, so if I go into my PC here, and if I look where Texture Packer has been installed, which is in Program Files, Code and Web, Texture Packer, I made this new folder called Exporters. Inside there's SDL. Inside there's a few files. The one you care about is sdl.txt, and you can see what this does is it exports a text file. It has its own little language and says, hey, for every sprite in all sprites, I want the sprite name, the x and y coordinates, and the width and the height, and I want to output this in a text document. That's what this Texture Packer exporter does for us. So it creates this file for me, and it creates this file for me so that I can access it. So this, just from a naming convention, is called the Texture Atlas, right? And this is the Texture Map. This is a map file or a data file that points to each texture in the sprite sheet. So example would be my bullet texture is at x1 and y1. That's the coordinate where it starts, the top left corner. And then it's a width of 16 and a height of 16. That's what it does here in the top left corner. Okay, so that's what this describes. So this describes the bullet, right, as an example. Okay, and sorry, I'm just going to make sure that you can see what I'm talking about here. And then the next one, if I was looking at, let's say, Megaman idle, you can see that there's 4 frames of animation, and they're not in order anymore. They're not like, you know, on the same level. There's different numbers of them, right? They're not even spaced out the exact same way. You can see that there's 1, 2, 3, 4 frames of animation for the Megaman animation for the idle, and there's 4 more frames of animation for the Megaman animation that is run. That's the run animation right here. This is the second part, right? Underneath the idle animation. And sorry, I'm just going to look here and see if you can see what I see, because my screen cap is going really slow compared to what I'm saying. Okay, you know what I'm going to try and do? I'm going to try and turn off my camera, only because I don't want, I think it might be taking it too much, too many cycles. So I'm just going to turn off my camera for a second. Okay, guys? Sorry, 1 sec while I do that. So you can't see the camera anymore. There we go. All right, so that might be a little bit faster in terms of, maybe it takes up a little bit less bandwidth now compared to what I did before. Maybe not. I don't know. Okay, so are you with me? Do you have this part? So this part is basically the, you know, there's 2 files that it generates. This file, the text file, and this file, the texture file. All right? Cool. So why would I need this? Can I do this on my own? Absolutely. If you really want to, you can go into some kind of application, let's say like Fireworks, Photoshop, Illustrator, whatever, and then you can place all your sprites in there manually, and then you can get the X and Y coordinates, so you can note those down and create your own little sheet that looks like this. So the process that we're using to put this on our operating system, this making the texture as well as making the texture map, is called serialization. We're encoding this you know, sprite sheet and this thing, right? So that way we've put it out on the system. We've saved it on as a file on the operating system. And now what we want to do is load it in. Okay, that's what we want to do. So if I load my project and run it for a second, let's see what I have. Right? Does it do what I've asked it to do? And let's see while we run it. And by the way, if you have any questions about what I'm doing, please put them in the chat window, and I'll do my best to answer you as I go. All right, so mine launched. Let's see if you can actually see it launch on your end. Oh yeah, lots and lots of lag, right, that I'm getting right now when I'm output. I find Blackboard Collaborate Ultra is good, but normally what I do is I use Zoom for making this work. Okay, so you can see now the scene has come up, and what I want to do is I want to press the 1 key, and you can see now that I have a little animation. Here it is, and I can do a run animation with my guy, right? I can also run to the other way, right? I can do that. And notice also I have my little plane on the top here, and my plane is spinning the propeller. So I have two types of animation here. I have the one that's at the bottom, which is my Megaman animation, and there's two. There's idle and run, and it runs to the right and runs to the left, and there's also my plane animation on the top. Okay, so that's what I have in terms of how I did it. Now, how did I do this? Because basically what I did was I loaded this sheet here, and I pointed to each different frame, right? And those are the frames that I'm animating. That's what I'm doing. So how did I do it? And you have a big delay here that's happening. By the way, you can also watch my stream up on YouTube if that's faster for you, right? Because you guys are a little bit delayed compared to what I'm doing. All right, so again, if I look at my solution, let's take a look at some structures that I've created to make all of this possible. So the first structure that I want to talk about is the frame structure. So here's my frame struct. Okay, my frame struct. And you guys should be able to see this now. So my frame struct is pretty simple. It's got a string, right, which is the name of the frame, x and y coordinates, as well as width and height. That's what they are. And what I need that for is for my my text file, right? That's the one I want. I want to see my text file with all the data, right? So again, if I look at my atlas.txt file, let me make sure I go to the right one. So desktop, I don't know how that closed, but whatever. So I'm going to go into my sprites and look at my atlas.txt. There it is. So you can see that this txt file, right, is exactly what I'm doing. I need somehow to define where I'm going to store each of these frames, and this structure is going to basically do it for me. The name is the first property, and then I have my x, y, width, and height, and that's how I'm going to deserialize it. Okay, we talked about serialization and deserialization. In your mind, you should think about encoding and decoding, right? So I'm encoding it as a string, right? And I'm decoding it back into some kind of viable structure here. So where I have a name, x and y, width and height. That's what I'm doing it. So I'm encoding it back into, or decoding it from the file into my program. Okay? So that's the first one. So the first one is this frame struct. And then I also have an animation struct. So what is an animation struct or animation? An animation is a vector of frames with a friendly name, like idle, like run, like die, like shoot, or whatever it's going to be, right? And each of these animations is something that I want my game object to have access to, right? So I want to go to the idle animation and print that out, or show it, to draw it, basically, every frame. Okay, so that's what these things are. So animation. The next structure that I have is also something new. It's the sprite sheet. So this is another another new structure. A sprite sheet has a couple things. One, it has a frame map. A frame map, right? Why is that? Well, because just like we have in our text file, here are a bunch of frames in the sprite sheet, and I want to be able to call up any one of these frames by their name. So if I say, hey, plane 1, come over to me. I want to to see plane 1, the plane 1 sprite. Then I just have to call this up, and it should just come up from the map, whatever the map is. Okay. So a map is, again, an interesting structure. There's two parts to it. There's the friendly name that you can put in as the key, and then the second component of a map is the value. So it has this key value pair relationship, just like, let's say, a dictionary. Okay, so how a map kind of works out. All right, so now that we have a map of frames, we need to be able to get frames. So there's going to be a way of me getting a frame, right? So I want to call the frame by name, and it's going to return the frame itself. I also want to be able to set a texture. I want to be able to add frames to my, my frame map. That's really what a sprite sheet is. It's just managing what frames are on that sprite sheet. So this is almost like a mirror of the data file. So it keeps track of all of this. That's all it does. And a reference to the related structure. That's what it does. So all of, and again, you guys are a little bit behind. What I'm seeing compared to what you're seeing might be a little bit behind. There might be a bit of lag. So again, I see, the frames, all the frames in a text file, and it keeps also track of the texture. That's what I'm doing. So those are two things that's keeping track of. Okay, are you with me? Hopefully you are. Okay. So next, let's go to the next part. So that's this part. So that's the three structures: frame, animation, and sprite sheet. Frame, animation, and sprite sheet. Okay. Well, the next one would be, I need to somehow draw this stuff. So if I wanted to modify my texture manager, so if I go to texturemanager.h, here's my texturemanager.h, I include sprite sheet and animation in there. That's what I'm doing. And then further down, what I want to do is I want to create a new load function from my sprites, which is called load sprite sheet. Okay. If I go to definition for this, then you can see that my load sprite sheet does a bunch of things. Okay, so there's a few parameters that it takes. One of the parameters is the data file. The data file is the text file. The other parameter is the name of the texture file. So that is like the actual sprite sheet itself, right? The third parameter is a friendly name for the sprite sheet. In my case, I'm going to be using Sprite Sheet. That's the name. Okay. Then I have set up a few things here. And this, by the way, this load sprite sheet is, I'm going to be using file loading to load the data file in. So I'm deserializing the data file. I'm taking the data in and I'm making use of it. That's what really deserializing is. I'm decoding it. Okay. I've encoded it in a certain way, right? So it's encoded in the right structure, the right format, the right, layout, if you will. And I'm pulling it from that layout and pulling it into my program. So the first thing is this input line. Yeah, do that. Let me rename this thing. Rename to input line. Okay, so input line, what it is a string that looks at each of the lines on my data file. So here's my data file. So each line is the input line. That's what it is. Okay. And then I have my data file itself. We're using a file stream structure for this. And I also have a delimiter. So let me just rename this to delimiter. A delimiter is just a separator. Okay. We can have different kinds of separators. One of the separators that you can have is a space, or you can have a comma. Comma separated files, right? Or comma separated values, or CSV files, are something that Excel can spit out, and it can also read. So that might have been another structure I could have used. But here, I'm just making use of a delimiter being a space. I can open the data file. Here's with the file name, and I've given it an instruction to open it in for reading only. That's what this is. This next line here, this on line 67. Okay. And then on line 70, what I've told it to do is, hey, let's create this temporary sprite sheet, right? And when I pass in the friendly name for the sprite sheet that I decided on, which is Sprite Sheet, okay? On line 73, I say if the data file is accessible, then on line 76, while I have a little while loop, while I can get a line from the data file, I want to pass in this input line string. Every line from the data file, I want to save it in the input line string. Okay. So what I'm doing is I'm taking the first line, when I first come through this while loop, and saving it. It's the first line from the text file. I'm saving it as an example inside of the input line string. Okay, that's what I'm doing. This first line, taking it, saving an input line string. Cool. Then what I want to do is I want to create a temporary frame. So on line 78, I want to make a temporary frame structure. That's what I'm doing. And this frame is something that I'm going to load up with data from the data file. That's what I'm going to do. All right, cool. So, and this is the line position, right? So instead of position, I'm just going to rename this thing on line 79, refactor, rename. Let's call this line position. Oh, if I can refactor, rename it properly. Line position. Okay. And line position starts off at 0. So that's the first line position. I also have a new vector of strings. These are little tokens, string tokens, or if you think about this as each of this whole line is going to be a string, right? And each line has little substrings. The name of the bullet, right? Each X and Y position. These are all going to be strings, this part. I don't care about the spaces. I just care about these little substrings. So there's going to be 5 tokens or 5 token strings per line. That's what it's going to be. All right? So that's what the tokens are. So then the first thing I do in my for loop, I'm going to do this 5 times. And this is the progressive way of reading and splitting up a string. That's what I'm doing here between lines 84 and 86. I'm using the progressive method to do this. And the way that works is I'm going to find the first delimiter, right? And I'm going to save that first delimiter as the line position. Okay, so again, if I look at the first delimiter, that's the first instance of the space. That's where it's going to be. It's position 0, 1, 2, 3, 4, 5, 6. So the 6th position on my line. That is where my delimiter is going to be. Okay, cool. And then I say, let's push back a new substring. All right, that's going to start from 0, the 0th position, up into, but not including the line position that I just specified. So it means that I'm going to take everything but not including the spacebar, and I'm going to save this as this bullet example string as its own substring. And I'm going to push it back to the tokens vector, right? And then I'm going to delete it. I'm going to input line erase. It's going to start from 0 up until line position +1. And so I'm going to go to line position. Usually the way it works is erase goes up to but not including this count. But I'm going to go up to and including this count. So it's going to say, let's erase this entire part. Right? So now my input line is smaller. And when I start off again, when I go back and loop again, it's going to look at the first delimiter, which is going to be this one. And then I'm going to separate this one off, make that the second token. Then erase all that. Then go to the next delimiter. Take this as the token. Erase this. And then I'm going to go to the third delimiter, and so on, until I'm at the end of the string. Once I've gone and done this 5 times, I have 5 tokens that are inside the token vector. And all I can do now, this is where the deserialization step happens. For each frame in my text file, I'm taking the first token, so for example the name, and assigning it to the frame name. The second one is going to be the X and Y and so on until I have the entire frame set up. I'm using the actual string as the name for the first one, but for the second one and on, I'm using this conversion string standard template string to integer. That's what S2I means, right? String to integer conversion to convert from a string to an int and save the result inside the X property of the frame struct. Okay, that's what's happening. And so on. It's going to do it for all those properties, right? Finally, after I've deserialized everything properly and saved all the objects inside of these integers and string, then I'm going to add my frame to my sprite sheet. Okay, it's this new frame. So that means that each of these frames, line by line, is going to be added as an object on the frame map of my sprite sheet. So I'm adding one line at a time, one line at a time. I keep doing that over and over again until the entire frame map is set up on my sprite sheet. Okay? Any questions around this? This is the first part of the loading. So I'm loading everything up, and I've loaded my entire text file, and I'm deserializing it, and I'm adding everything to the sprite sheet. That's what I'm doing here. Okay, cool. So then I close off my data file. So I do that, close off my data file. And then on line 108, I load my texture file, and I get a reference to the texture, and I set it inside the sprite sheet. So the sprite sheet has a reference to the texture that's related to it. Okay? That's what this is. And then the texture manager itself has a sprite sheet map. Again, another map. So if I look at the texture manager and if I scroll all the way down to the bottom, you can see that on line 84, there is something called the Sprite Sheet Map, which is another map of friendly name. The key is a string, and there's a sprite sheet pointer that I'm looking at. So the sprite sheet pointer is the value, so key value pairs. So Sprite Sheet Map is where I'm going to be storing each of the sprite sheets. Now there's only one in this case, but I can have multiple sprite sheets that I store in here. For example, I can store the foreground tile map, the background tile map, the tile map or the sprite sheet for my character, my Megaman. I might have a sprite sheet for his enemy. I might have a sprite sheet for a bunch of other stuff, something in the scene. But I can have multiple sprite sheets, and I want to store them all in here. Okay, so that's really the texture manager's job so far, is just loading the sprite sheet and then storing them. But how do I display each of the sprites? How do I play the animations? Well, there is a play animation function. Let's go there. Let's go to definition. So my play animation function does the following. It says, okay, I need a friendly name for the sprite sheet. So I'm going to say, hey, this is the sprite sheet. It's called sprite sheet in this case. All right. I also need an animation that I want to play. Remember an animation, what it is? An animation is a vector of frames with a friendly name. That's what it is, right? Vector of frames meaning I have more than one frame of animation that I'm going to play typically. Okay. Then I'm going to have X and Y coordinates where I'm going to show this thing, a current frame object, an integer where the current frame is. Now again, I can probably bury this current frame inside of the animation struct. I haven't done that yet. It's right now it's part of every game object that uses this animation has its own current frame. But eventually I want to try and bury this, so I don't have to even include this here. I can just get it from the animation itself, which is the right thing to do. I also have a speed factor. The speed factor is set for this particular animation. I could set the animation also, the speed factor inside the animation struct, right? Then I have a renderer, the angle that I want to show this thing, an alpha transparency mode, is it centered or not, and what do I want to flip it? Okay, that's what this play animation does. Those are all the parameters. I calculate the total frames by looking at the animation frame size. So for example, if I had 4 frames of animation, then that would be the total frames, right? And then I want to calculate the animation rate, and I say total frames. So let's say, for example, there was 8 frames divided by 2, that would be 4, and that would be the animation rate. And just like I did last week, I'm just going to get the number of frames. Think about this as getting ticks. I want to get the number of frames. I want to divide them by the frame rate, and when I have no remainder, right, because this modulus is going to return a remainder or not. When I have no remainder, then that means I'm skipping every 4 frames, every whatever the number is you're going to get from the animation rate. All right, and then I'm updating the current frame. Again, I'm doing it for anything that has any animation that has more than 1 frame of animation. If there's only 1 frame of animation, I just want to show that frame, and that's it. And there's examples of this where I only have 1 frame. For example, the restart button only has 1 frame of animation. The start button has only 1 frame of animation. So does the bullet, the cloud, and the island. They only have 1 frame of animation right now, right? So I need a way of only showing those as well. And in a tile map set, you're only going to typically have 1 frame of animation for every tile that's on there. Now, when I say animation, it's just 1 frame that has a friendly name attached to it. Okay, that's all. So going down here, after I've I've moved the frame, what I'm looking at is I'm going to start looking at the texture map, which is my sprite sheet, and I'm going to start looking at the X and Y coordinates according to the current frame that's active. Each current frame. So I'm looking at the texture locations, X and Y, then width and height, and then I'm taking this and copying it to the destination rectangle just like normal and outputting it to the screen. So that's what my play animation does. Play animation literally just takes a look at the animation, and I cycle through each of the frames and I output it at a specific rate out to the screen. Okay, questions around this? So this is the texture manager. Okay, cool. So these are basic components enough for me to start going. Right now, yes, this is great, but I need to be able to implement this, and I do this first of all in two game objects. So if I go back to Solution Explorer, the first game object, here's my game object, is the planeSprite.h. So planeSprite.h and planeSprite.cpp describes my game object. I include animation.h here, SpriteSheet.h, as well as an unordered map. Remember, we also have a map for this too. And I could have made my own sprite class, but I decided for now not to do that. I'm just going to make it, the plain sprite is just a fancy display object. That's all it is, okay? I have a new function called build animations, right? And what build animations do is it kind of adds to the animation map. That's what it does. Notice I have a map here as well. I'm using several maps. So this map here basically says, hey, what is the friendly name of the animation? For example, idle or run. And then get that animation, the one that I'm looking for, right? It also keeps track of the sprite sheet that's related to the animation, as well as the current frame, which we talked about might be best put inside the animation itself. Okay? So that's the actual plain sprite. Plain sprite does a couple things. It loads the texture manager sprite sheet. So remember, the sprite sheet's made up of the texture map, which is the texture map is a map or a text file, which is this thing here. That's what this is. The next part is the texture file itself, which is also called the texture atlas, and that's what this second part is, right? Followed by the sprite sheet name, a friendly name for the sprite sheet, and the renderer. Okay, so that's what this does. I keep track of the sprite sheet by using the texture manager instance get sprite sheet. I kind of made that so I can get a reference to the sprite sheet. However, I probably could have encoded the load sprite sheet differently. Instead of returning a Boolean, maybe I could have made it return a reference to the sprite sheet itself. Okay, that was loaded. That's a choice I could have made from a programming perspective. Okay, but I didn't. And then I want to set the frame width and height. This is more like the object width and height, 65 by 65, right? The position and so on of the plane. And I call inside the constructor function, I call the build animations function, which is on line 26. So what does build animations do for me? Well, it does this actually. So it creates a temporary animation. We call it plain animation. We named the temporary animation as plain because there is only one animation. It's just the propeller moving, right? And then, and this is kind of like a little weird, but I push back the 3 frames of animation. Plane 1, plane 2, and plane 3. Where did I get these names? Here, from the texture map, right? Plane 1, plane 2, plane 3. The way I've done it, I don't have to remember the actual frame number. All I have to remember is the frame name. Plane 1, plane 2, plane 3. I don't need to know that it's number frames, I don't know, 12, 13, and 14, or whatever it is. I don't need to know that. And I don't know which frame this is. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, 11, 12, and 13. I don't care that it's 11, 12, and 13. I don't care about that. I care that it's plane 1, plane 2, and plane 3. Okay, so that's what this is. So I load up those sheets, those frames, and I add it to the animation. And then I make a friendly name for the animation. I name it as plane. That's what it is here. And I make a reference to the plane animation that I store inside of my my game object. Okay, so that's what happens when I build animations. I could have more than one or just one. In this case, I only have one little animation. That's the propeller that moves, right? Up above, then, I want to be able to draw it. And the way I do that is I get the sprite sheet to draw. So here's my sprite sheet that I'm drawing. The name for the animation that I'm drawing, so in this case, plane. The X and Y position of where I'm drawing, my current frame that I'm storing here, a speed factor, the renderer, the angle, the alpha transparency, and if it's centered or not. And that, my friends, plays the animation. Okay, that's what takes care of the plane. Okay. More complex is the Megaman animation, and I kind of rejigged the one that we did last week. So I have this thing called player.h and player.cpp. Under player.h, I do the same things. Now, this is where, in your mind, you should think, hey, this needs a superclass, because I'm doing the exact same things. There's a lot of duplication here. So that kind of says, I probably need some kind of superclass for this. Okay? So I have the same things. Build, my sprite sheet, my current frame, as well as some kind of unordered map that I keep track of animations. Same idea here for the player.h. Where it goes differently is player CPP, because I also have a current animation state of player idle right. And again, I defined last week several animation states. I said that there's 4 different animation states: idle right, idle left, run right, run left. Those are the 4 animation states that I defined last week. And I'm just setting the same thing up this week. Okay, nothing different here. I'm loading up the sprite sheet if it wasn't already loaded. Now I know I've already loaded this from the plane animation, but that's okay. And then, because it won't load it again. And then I set up the frame width and frame height, kind of like the object width and object height. And notice that I'm choosing 53 by 58. Where did I get that? Well, I look at the Megaman animations, and I noticed that the greatest value for the width is here with Megaman run 0. That's when he's the widest, 53. And when is he the tallest? Well, it looks like 58 is when he's the tallest, and several frames that he's 58. So I've picked the widest and the tallest frames to make my game object bounding box. That's what this is. Okay? My game object bounding box for those 2 properties. That's on line 12 and 15. Okay, cool. So I have my building blocks here, and then what I want to do is I play the player, I build my animations just like before, right? And now my build animations looks a little bit more. Again, could I have done this differently? Yes, I could have. I could have had a for loop run through here, but I'm defining 2 different animations, an idle animation and a run animation. Okay, pretty simple. Idle and run, right? And I add them both, the idle animation and the run animation, to the animations map. That's what I'm doing here. I'm adding them into the animations map. Cool? So once I've got them done into the animations map, just like before, we can draw them. So there's the drawing. And the way it works is this. I say, depending on the state, if I'm player idle right or player idle left or run right or run left, I'm going to play the different sprite sheets. So either idle or run. The only difference is when I'm idling to the left, then I also want a SDL flip horizontal. Or when I'm running to the left, SDL flip horizontal. So that's what I'm doing here. Okay? So I'm just using those functions. Okay? So far, so good. Excuse me, I'm losing my voice. So that's how it works when it comes to the Megaman stuff. Now, how do I implement this? I do this inside of the level 1 scene. So if I go to level 1 scene under scenes, so level 1 scene.h and level 1 scene.cpp, here it is. So in level 1 scene.h, what I'm doing is I'm including both player sprite and player.h. And on the bottom, I have plane sprite and player. And both those 2 things are going to be pointers. And I simply, at the bottom, just in the start function, I instantiate a new plane sprite and a player, and I add both to the display list. And now the display list simply takes care of itself. It just draws and updates every object in the display list. And again, if I run it, you can see that I'm getting exactly that. Okay, now that I've explained everything, and you guys are all experts, all right, on this thing, right? I want you guys, there's going to be a bit of a challenge that I want you guys to undertake. Okay? So here's the challenge. What I want to do is I'm going to give you an animation for an explosion animation. And I've done this already. So up on line, up on Blackboard, if you notice, I've given you this assets version 2, right? And this is where I got the animation, all the frames for the animation. So assets version 2, right? I'm just going to go there and grab it right now. So I'm going to go to so here's assets version 2. I want to grab from my assets version 2 inside the images folder. I want to grab explosion 1 through 7. Okay, explosion 1 through 7. I'm going to copy these images, explosion 1 through 7. And you're going to see what they look like in a second. And I'm going to put them inside my project structure. So again, going back to where I was. I'm here. I'm going to go into assets, textures. And I want to put my explosions in here. So Control V. There's my explosion structure. Okay? Nice. So my explosions, I want them to be inside of Texture Packer. So again, if you have access to Texture Packer, this is how it would work. I just take these explosions, the explosion sprites, and drag and drop them into Texture Packer like so. Okay? And now you can see that when I drag and drop them in, that I have a bunch of explosion sprites that are part of the texture map now. Okay, but now there's a problem. Wait, if I do this, I've changed my texture map. You're going to say, wait, but if I do this, isn't it going to mess things up? Well, no, it's not. For example, now that I've dragged and dropped it in here, and if I press the Publish Sprite Sheet button up here, it's actually going to rejig the text file as well as my texture map. That's what it does. So if I close this off, my text file off, and if I close off my atlas for a second, and then I reopen them, so go back to assets, sprites, and reopen my atlas.txt, as well as my atlas.png, you can see that, well, everything is back to normal, right? All the stuff that I wanted is been output. In fact, the great thing is it rejigged my text file completely by itself. Oh my gosh, this saves me so much time. Imagine if I had to add those explosion frames by hand. I would have to go through this thing, move all the frames around if I wanted them in alphabetical order or something, and it would be a mess, right? Or maybe I'd add them to the end. I'd still have to go through and annotate each one of them and which ones they were and where they exist on the Sprite Sheet Map by myself. That's too much work, right? So here's your challenge. Now that you have the explosion animation, you have 7 frames of explosion animation, what I want you to do, and by the way, I put the final version up on Blackboard, so just in case you don't have Texture Manager or Texture Packer, right? I put the final sprite sheet here. This final sprite sheet includes those 2 files. It includes the new atlas.png and the new atlas.txt. That's what it includes. So you can just replace the ones you have with atlas.png, the new one, and the atlas.txt. So that's the final version. So you don't have to use Texture Packer if you don't have it today. Okay? But here's what I want you to do, going back to the challenge now, and I'm going to give you some time to do it. Okay? Here's what I want you to do. When I run my code, right? And by the way, let's see if the code runs now, right? Because, you know, we mess things around, right? We don't know if the code's even going to run, but of course it does, right? So it actually looks at different positions right now. It's already read the file, and it's already looking at a different position on my sprite sheet. It's already working. Okay, because this is why it's showing this information already. Okay, so here's your challenge. And I'm going to stop the recording while I get this done, right? You have 15 minutes. And what I want you to do is wherever I press on the screen in my level 1 scene, right? I want an explosion to appear. And then it's going to go away. that means there's 7 frames of explosion. After the 7th frame, it's not going to show that explosion anymore. Now, there's a couple ways to get this done. One way is to instantiate new explosions every time and then destroy them. That would be bad. The better way to do this is to create what I want to call an object pool. And if you look at the design patterns book that I keep sharing with you, game programming patterns, right? Under object pool. So again, where is this game programming patterns book? I've shown you this before. It looks like this, gameprogrammingpatterns.com. And if you go down to the web interface, and if I look down, there is a section here where optimization patterns exist. And I want you to look at the object pool optimization pattern. How does this work? Well, imagine if I had multiple, multiple explosions here, and I put them together in a row. I have explosion number 1 and explosion number 2. And then, for example, let's say I delete something. So here's an example with foo bar. I delete foo, right, in this case. And then you can see that bar is the only thing that's left. But then I want to put another bar in, maybe another 2 bars. Notice that bar is bigger than what position that foo had. I can't take this bar and put it in the same slot that's left over in memory as an example where foo was. So what we have is I have to put this somewhere else. And because of this, there's a slot in memory that's empty, so-called memory fragmentation. We actually lose memory, even though we might have a lot of memory. We can fragment our memory, so it seems as if our program takes up more memory than it does. And also, this is computationally expensive. So whenever we instantiate and destroy stuff, it takes cycles, right, for us to do that. Instead of doing this, what I want to do is I want to create reusable game objects, which is what this pattern is all about. Okay? So how do I make use of the reusable game objects? Let's draw it out. So I need some kind of container. All right? So here's the container I want you to think about. So here's a container. All right? Let's suppose this is the container of game objects that I want to create. Right? Inside my container of game objects, I'm going to have several explosions represented here by circles. So let's say I'm going to have my first explosion. I'm going to have my second explosion. I have my third explosion. I have a bunch of explosions in here inside of a pool, some kind of container. Okay? So each of these explosions I want to reuse, right? And what I want to do here is I want to use a structure that you can see that's very queue-like, right? Queue, as in a queue structure. And you guys should know what a queue is. A queue has a certain property, right? It's got a first in, first out property. All right, you guys are going to learn more about this in your algorithms class, right? But this first in, first out property means that it's like first come, first served. So at the head of the queue, which is the top of the queue, or the front of the line, if you will. So here's the front. All right, this is the front. And then we have the back. I'm just pointing this out for you, right? So here's the front, here's the back. What I want to do is I want to pop the first element or the first explosion from the front of the line, right? This is what I want you guys to try and do. So pop this from the front, right? And this is going to be the, there's actually a pop function for this, right? Then I want you to copy it. I want you to look at the front, copy it, and then what we want to do is we want to recycle it by putting it back onto the back. We want to push it back to the back of the line, right? So we pop it off and push it to the back of the line, and it's called a push whenever we push things onto the back, right? So we want to push to the back, we want to pop for the front, right? And then what we want to do when we're pushing or popping off the front is we want to do two operations. We want to copy the front element. That's the explosion. So I want to copy the front element. Okay. And then what I want to do is I want to set that front element as active. So set active. Because by default, anything that's inside of the actual structure should be inactive, right? You should only set the object active when it leaves the front. It's going to be pushed back into the back as active, but somewhere along the way it's going to be turned off again. Okay? In other words, I'm going to have objects that are set as active and set as inactive. And they're going to keep moving from active to inactive state. Okay? That's what's going to happen with them. Questions around this structure. This is really an idea of an object pool. I'm going to continue to use this. By the way, you can use this for bullets, enemies. You can use it for obstacles, anything else, particles, whatever that you want to reuse over and over again. Okay? Backgrounds, right? You don't, whatever you do, you don't want to instantiate new stuff very often. There are going to be some cases where you have no choice. But for the most part, you want to reuse as many objects as you can. So object pooling is a really cool thing. All right, so challenge. Again, going back to the challenge, right? So this is what I want you to do. And going back to what I'd like you to do here is when you run the code, right? Then wherever I click on the background here, whether I click on the top or wherever, anywhere I click, I want an explosion to show up. And then after a few frames, it's going to disappear. So make sure you build your explosion class so that it only plays 7 frames of animation. And when it's done, it goes inactive again. So the explosion class should have both an active state and an inactive state. Okay, if that makes sense. Any questions before you do your little challenge? Okay, I'm going to stop recording and I'm going to take a small a break. And when I come back, I'm going to come back at 1:15, and when I come back, I'm going to show you the solution. All right, so let's do that now. So I'm going to go back up to here and I'm going to stop the stream.